Good day, everyone. Good day, Sir Dimitelio.
I am Shanaril Tadim.
I am Juliet Marie.
I am Lucem Daguplo.
I am Christine Jade Dalayan.
And we are the Group 7.
Today, we are going to talk about another instructional strategy in mathematics. But before anything else, let us have a game first. This game is called Guess the Word by Pictures. In this game, you will look at the pictures I have given and you try to guess what they are conveying. Am I clear? Okay, so are you ready? Here are the pictures. Out from the game that we had earlier, who has the idea about what we are going to discuss today? Yes? Thank you. So, today we're going to talk about using manipulatives as instructional strategy in mathematics. So, what are manipulatives? Horan and Carr in 2018 defined manipulatives as concrete objects that allow students hands-on experience while being actively engaged in the learning. It is the physical and visual tools that the students can handle to help them learn about a concept. Manipulatives can be anything physical that the students use in a learning activity. Now, what are manipulatives in mathematics? Manipulatives are tools that are used to help students visualize ideas. These are objects, charts, and activities that are used in mathematics education to engage learners and help them develop their math skills. So they come in many shapes and sizes. And research shows that using them has a positive effect on students' understanding. So the purpose of using manipulatives is to make abstract mathematical concepts more concrete and tangible, allowing students to explore and understand mathematical ideas through hands-on activities. In the classroom, teachers are using manipulatives in a lesson as they introduce, practice, or remediate a mathematical concept. These physical tools may include a variety of concrete objects that might be used at the elementary level, such as counters, fraction strips, patterns, block, cube, geoboards, and others, for all kinds of math instruction.
Thank you, Shana. Few manipulatives might be used in teaching mathematics at elementary level. For numbers and operations, we can use counters, place value maths, base 10 blocks, money in coins or bills, and fraction strips. First is counters. It can be used to teach one-to-one correspondence, ordinal numbers, and basic addition and subtraction. Two-sided counters can be used to model one-to-one correspondence, addition and subtraction, or skip count. The second is place value maths. These can be used to show each digit's place value when using base 10 blocks. Number 3, base 10 blocks. It can be used to model the variety of ways a number can be represented and to model regrouping when adding, subtracting, multiplying, and dividing. The fourth is money in coins or bills. Can be used to count, skip count, or model regrouping when adding or subtracting. The fifth one is fraction strips. Can be used to show equivalent fractions, to add fractions, to subtract fractions, or to find common denominators. For algebra, we can use pattern blocks, attribute blocks, and pan balances or scale. The first is pattern blocks. It can be used to create, find, or extend patterns. The second is attribute blocks. It can be used to sort and classify according to shape, color, size, or other attributes. Third is pan balances or scale. So this can be used with objects or weights to show equivalent values. Now for geometry, we can use geoboards and geometric solid models. The first is geoboards. So it can be used to identify simple geometric shapes and can describe their properties and to develop spatial sense. Second is geometric. The second is geometric. So this can be a solid models can be used to teach nets or spatial reasoning. Next, we have measurement. So in measurement, we can use standard and non-standard rules and measuring cups and tiles. The first is standard and non-standard rulers and measuring cups. So it can be used to represent length and volume. Second, tiles. So tiles can be used to find the area or the perimeter of an object. And finally, for data analysis and probability, we can use spinners and number cubes or dice. First, we have spinners. So, what is spinners? So, spinners can be used to find the experimental probability of landing on a designated area. Next, we have a number cubes or dice. So this can be used to find the experimental probability of rolling a certain number or a combination of numbers.
Thank you, Juliet. Now, there are advantages of using manipulative as instructional strategies in teaching mathematics. First is concrete understanding. Manipulative help in making abstract mathematical concepts more tangible and easier to understand by allowing students to physically interact with them. Second is engagement. They often increase student engagement and motivation by providing a hands-on approach to learning, making lessons more enjoyable. Third is problem-solving skills. They can aid in developing problem-solving skills as students manipulative objects to solve mathematical problems. Fourth is differentiated learning. They cater to various learning styles, allowing students to learn at their own pace and in ways that they suit their individual needs. For the advantages of instructional strategies in teaching mathematics, first is limited applicability. As students progress to more abstract mathematical concepts, the direct use of manipulatives may become limited or impractical. Second is dependency. There's a risk that some students might become overly reliant on manipulatives, struggling to transition to mental or abstract methods. Third is time consuming. Introducing manipulatives in teaching might take more time than traditional methods, potentially affecting the pace of the curriculum. Fourth is logistical challenges. Using manipulatives might require additional preparation time and resources, and managing them in a classroom setting can sometimes be challenging. Overall, while manipulatives can be powerful tools in teaching mathematics, their effectiveness largely depends on how they are integrated into the curriculum and used in conjunction with other instructional methods.
Using manipulatives in math instruction can be beneficial for students. Here are steps to incorporate manipulatives. First is to select appropriate manipulatives. Choose materials that align with the mathematical concept being taught. For example, base 10 blocks for place value or geometric shapes for geometry. Second, introduce the manipulatives. Begin the lesson by introducing the manipulatives, explaining their purpose, and demonstrating how they relate to math concepts. Third, model the concept. Use the manipulatives to model and demonstrate the mathematical concept. This helps students visualize and understand abstract ideas in a concrete way. Fourth, guided practice. Allow students to practice using manipulatives with your guidance. Provide opportunities for them to manipulate the objects and solve problems collaboratively. Fifth, independent practice. Gradually transition to independent practice. Encourage students to solve problems on their own using the manipulatives to reinforce their understanding. Sixth, facilitate discussions. Foster class discussions about the mathematical concepts and encourage students to explain their thinking using the manipulatives. 7. Connect to abstract representations. Relate the manipulative experiences to abstract representations, such as symbolic notation or writing algorithms. Help students bridge the gap between the concrete and abstract. 8. Review and reinforce. Periodically revisit the use of manipulatives to reinforce concepts and address any misconceptions. This helps to solidify understanding over time. And the last step is the assessment. Assess students' understanding through a variety of means, including observations, discussions, and written work. Evaluate whether the use of manipulatives has contributed to their conceptual understanding. Remember, the goal is to gradually move from concrete to abstract representations as students develop a deeper understanding of mathematical concepts.
Overall, using manipulatives offers a way for children to grasp concepts through hands-on experience. Teachers should learn how to use manipulatives so they can successfully engage the students in the classroom. You can design a plethora of activities using concrete manipulatives to explain difficult mathematical concepts. Teachers must deliberately and carefully choose all manipulatives being used and pay special attention to the sequence of introducing these manipulatives to maximize effectiveness. So, there is enough research evidence to believe that using manipulatives over extended periods of time has a positive effect on students' learning patterns.
Now that we are done with our reporting, we will proceed to our teaching demonstration. We will act as your teacher and you will act as our grade 4 students. Good morning, class. So I have here a butterfly. So what can you observe with this butterfly? Okay, as you can see, it has the same exact side. So when we fold this butterfly, it will mirror one side. So what do you think is our lesson for today? Okay, who has an idea? Yes? Okay, our lesson for today is all about symmetry. Now, do you have an idea on what is symmetry? Okay, with that, we will proceed to our discussion. Now, let us all read together. Symmetric means that the figure forms two equal parts or mirror image of the other when folded. So symmetry is when something can be divided into two equal parts. It is like a mirror image of itself. For example, if you fold a piece of paper in half and both sides look exactly the same, it is symmetrical. So the line that divides the figure into two equal parts is called the line of symmetry. So here are other examples. This tree is a is an example of symmetry. Because when we fold this one, it will mirror the other side. And also with this footprint. Now I also have here another example. I have here a ano ni? Kite?
Kite.
Idoon lang ka na.
Oh, sige, go.
So I have here a kite. So this is also an example of a symmetry. Because as you can see, if we fold this, it will mirror the other side. Both sides is equal. And also I have here a triangle. So this is also an example of a symmetry. Because as you can see, if we fold it, it will mirror both sides. So the heart has one line of symmetry while the square has 4 lines of symmetry. So I have here the heart figure. So as you can see, if we fold this, and this is the line of symmetry. So it has 1 lines only. Because if we fold this horizontally, it will not mirror both sides, or it doesn't have equal sides. But if we fold it vertically, it will if we fold this heart vertically, it will mirror both sides and it has equal sides. And also the square has 4 lines of symmetry. So I have here also an example of a square. So a square has 4 lines of symmetry because as we fold this 1, 2, 3, and 4. So it has 4 lines of symmetry because if we fold this 4 times, it has equal and the other side will be mirrored. So this is an example of a symmetry. Symmetry can be found in many things around us, such as buildings, furniture, and even nature. It adds balance and beauty to our world.
So there are figures that don't have line of symmetry as shown below. So like this one, and this one. So they are called asymmetric. So asymmetrical objects are those that lack symmetry. Symmetry again refers to when one half of an object is mirror image of the others. So an asymmetrical object doesn't have this property because its halves aren't identical when divided along a central line. So for example, this one. So as you can see, this one, when I fold this one into half, it will not mirror the other object, and when I fold this one, it will not form into 2 equal parts. Do you understand? Okay, again, so asymmetric is the figure that don't have line of symmetry.
Okay, class, now that you have already learned what is symmetric and asymmetric, let's have an activity. So, class, I have some different figures. So, for your activity, I will group you into 4 groups. Each group, I will distribute these figures, and I want you to observe and identify whether it is symmetric or asymmetric. I will give you 5 minutes to answer this activity.
Do you have any questions about the figures given? Okay, you make sure that each of the members of the group gets to observe and hold the figures. Are you done, class? Pass your papers. Again, what is symmetric? Yes? Okay, how about asymmetric? Okay, what do you call the line that divides the figures into 2 equal parts? Yes? Okay, thank you, class. Now, Now for your assignment, choose one object that has symmetry. Draw it on a bond paper. You can color it or use any materials to make it more attractive. Okay, that's all class. Thank you.